Welcome everybody. We are just beginning the webinar and we'll take a minute or two to allow all of our attendees to come in from the waiting room.
Thank you, Cassie. We give folks until 2:02 on my computer. We like to be very timely. Hey, Anya.
Hey, how's it going?
I hope everyone's having a great summer. It's going by too fast, right? Okay. Well, I will get going. We are broadcasting and recording. This is a special briefing meeting of the Maine Climate Council. My name is Hannah Pingree. I'm the co-chair of the council and head of the Governor's Office of Policy, Innovation, and the Future. And this is a special briefing to talk about the DEP's biennial emissions report. And that is really the work of my co-chair, Commissioner Loism, whose agency leads the really heavy lifting on this. This is obviously the real important metric of how are we actually doing. So Melanie will put this in context. Obviously, this data doesn't reflect all of the heavy lifting of the Maine Climate Council. That's coming in the next one, but it's great to see you all here. I know a Zoom meeting in August is not always on the top of the radar, but there's some good news in this report, and it got some good press attention when Melanie's team put it out last week. So I will pass it off to Melanie for a little more context.
Thanks, Hannah. Good afternoon. I'm Melanie Loism, Commissioner at the Maine Department of Environmental Protection and co-chair with Hannah of the Maine Climate Council. Joining us today and presenting in just a moment is Stacy Knapp, the manager of our emissions inventory program at the Maine DEP. So for just a quick context, what you all already know, state of Maine has emission reduction goals for greenhouse gases in law. Some of those goals have been in place since 2003, and the Maine Department of Environmental Protection has been required to report on greenhouse gas emissions and to measure our progress towards meeting those goals since 2004. So you'll see our reports referred to as the Ninth Biennial Report. This year, the report did contain some additional information that Stacy's going to be going through as a result of changes to the law that were made in 2019. So in 2019, Maine's law became much more explicit about what emission reductions we are supposed to be measuring. So now we are specifically required to measure gross greenhouse gas emissions as well as net greenhouse gas emissions. The department did adopt a rule last year to clarify the methodology that we use to do those calculations. In years past, every time we put out the report, we got the same questions about how we came up with the numbers. We've basically been using the same methodology for all of these years, although now it's been enhanced with the work that was done in coordination with the University of Maine to develop the carbon budget to help with the sequestration calculations. So as Hannah sort of alluded to, one of the limitations of the work that we do is that we're using data sets that often take a couple of years to become fully available to us. So whenever we do these reports, we're always looking back in time, which can be a little frustrating because, you know, this is 2022 and we want to know how much progress we made since Maine Won't Wait was adopted and has been implemented. We'll have some of that information in the next biennial report, but this biennial report really takes us up to 2020. So in some ways, it kind of gives us a baseline to compare to the years that come after to see how emissions will change in the years moving forward as we implement Maine Won't Wait. So with that, I will turn it over to Stacy to walk you through the report that we've just come out with and give you some of the details about her assessment.
Excellent, thank you. So as Melanie said, I am Stacy Knapp and I head up the emissions inventory section at Maine DEP. And we're here today because I have the results of the most recent greenhouse gas inventory. So let me share my screen with you and we'll get started. Here we go. Okay. Okay, can everyone see that all right? Yes, okay, excellent. Okay, so now these data, as Melanie said, are hot off the press. So we just released the Ninth Biennial Report at the end of last week. And let me add this report is excellent beach reading. So if you haven't read through it already, just a suggestion. Now, for those of you who have already dug in, I love this stuff. So I'm here to answer all of your questions. But first, in case there are a few who have been on vacation and haven't had a chance to fully digest it, let's jump in and go through some of the highlights. Now, if you can remember, back in early 2020, I shared the data with you from the 8th Biennial Report. And while the results of the 7th Biennial Report, which had data through 2015, showed a slight increase in emissions, which had us concerned, the 8th report with data through 2017 showed decreasing emissions again. And it really looked like we were going to meet our 2020 goal, but we needed 2 more years of data. And now we have it. So here it is. Now, we are going to break this down a lot, but here's the figure most of you are here to see. So first off, I am excited to announce that we did meet our 2020 goal. I know it says 2019 here, but the data presented in this report include through December 31st, 2019, and the goal is for January 1st, 2020. So we get to take that one now. Okay, let me explain what you're looking at here. This figure shows a time series of gross greenhouse gas emissions. So gross greenhouse gas emissions are the sum of all anthropogenic greenhouse gas emissions released to the atmosphere by all of the sources within the state every year, regardless of how much carbon is sequestered in the environment. So emissions up only, no sequestration down. Now, looking at this figure along the bottom, the horizontal axis, we can see our reporting time frame for this report. That's 1990 through 2019. And the vertical axis is the amount of emissions in units of million metric tons of carbon dioxide equivalent. So you're going to see these same axes on most of our figures. The green line at the top is the total. That's the line we use to assess our progress toward meeting our goals. The blue line below represents CO2 emissions from the combustion of fossil fuels. So in 2019, for example, the emissions of CO2 from burning fossil fuels account for 60% of Maine's gross greenhouse gas emissions. The other lines on this figure are our reduction goals. So those are the gray dashed lines. So we have 10% below 1990 levels by 2020, 45% below 1990 levels by 2030, and 80% below 1990 levels by 2050. So let's get back to our green line, the gross greenhouse gas emissions at the top there. You can see we were at 32.2 in 1990, and emissions rose from there, peaking in 2002 at 38.5. And we've since seen a decline since 2002, primarily due to a decrease in the use of high carbon fossil fuels. And by 2012, emissions were below 1990 levels, but they rebounded slightly between 2013 and 2015. Now, thankfully, gross greenhouse gas emissions have been trending downward again through the end of 2019, as you can see here. Now, to meet our 2020 goal, we needed gross greenhouse gas emissions to be 29 or lower. That's 10% below the 1990 levels. And we were at 24.2, so we did it. In fact, we see a 25% reduction in gross greenhouse gas emissions between 1990 and 2019, and a 37% reduction between that peak there in 2002 and 2019. Now, let me add that the data in this report predate Maine Won't Wait. So as Melanie and Hannah said, this data is not representative of those strategies. And as you know, the Climate Action Plan was released in December of 2020. And so the next report will include data through 2021, and we expect to start seeing results of some of those strategies laid out in Maine Won't Wait. So let's start breaking this down and looking at the details a bit more. First, let me talk about what's new in this Ninth Biennial Report, and Melanie touched on a couple of those things, but there are some very important additions. So as you know, in addition to our gross greenhouse gas reduction goals, we are also required now by statute to achieve carbon neutrality by 2045. Now, while we can track our progress for the reduction targets using the gross inventory, we need a net inventory to track our progress toward carbon neutrality. So a net greenhouse gas inventory includes the gross anthropogenic greenhouse gas emissions we spoke about in the previous figure, minus the greenhouse gases absorbed by greenhouse gas sinks, either natural or man-made. These include things like trees, crops, soil, and wetlands within the state, just as a few examples. So this report is the first time we've included a net inventory. And with that, we now have a much more comprehensive understanding of the full carbon budget in the state. Now, because we're quantifying sequestered carbon now, we also have to start looking at biogenic emissions. So this includes emissions from burning renewable fuels such as wood, ethanol, and biodiesel, as well as emissions from things like municipal solid waste combusted, landfill off-gassing, and methane that's flared. So another enhancement we've made to the analysis is including fugitive emissions from natural gas distribution systems. And finally, we've added a section of data quantifying emissions based on electricity consumption as a comparison to emissions from electricity production. And we'll talk about that more later. So let's back up a bit and let me explain our analysis a bit and where we get these data. So first, I'd like to direct you to the department's new rule, that's chapter 167, which outlines the methods used to track and report both gross and net greenhouse gas emissions. So this is a very detailed rule, and that is the best source for the how, and it will be updated regularly. So for the development of our gross greenhouse gas inventory, I'll give you a little bit of the methods. And again, chapter 167 is your go-to source. But we primarily use EPA's state inventory tool. We fondly refer to this as the SIT. Now, this tool is publicly available if anyone wants to download it and check it out. It's quite fun. And I provided the EPA website for you here. Now, the foundational data set used in the SIT is from the US Energy Information Administration. So they collect lots of information about fuel used by states all across the country, and they combine all of that data along with other details from federal and state agencies into this gigantic model of consumption. And it's called the SEDS, or the State Energy Data System. So this data set includes consumption of all types of energy, including fossil fuels and renewable energy sources. And the SIT pulls that energy consumption data in along with a number of other data sets and models, and tries to fill in the gaps to estimate greenhouse gas emissions by state. It is extremely comprehensive. Now, this is a starting point for us, but we make it better. So we have some data for Maine that federal agencies don't have, and we're able to make those changes in the SIT where we know our data is better. So this way, the results best represent actual emissions in Maine. And we want to ensure that the results for Maine are as accurate as possible, which is why we make that effort. So we enter in and add data such as vehicle miles traveled, solid waste landfilled, and now biogenic emissions, just as examples. As we've already spoken about, this is the first greenhouse gas report to include a net greenhouse gas inventory. Now, this net inventory was a major undertaking by Maine scientists, and you could read more about the methods in chapter 167. But for simplification, I'll just say that the general method is to quantify the carbon emitted and subtract from that the carbon sequestered. So this is done for a number of different categories, as we'll see later, and it's compiled into a full carbon budget showing the flow of carbon. Now, before we jump back into results, I want to clarify some units and terms that have prompted questions in the past. As you'll see throughout this presentation and the greenhouse gas report, there are two primary units that we use to report greenhouse gas emissions. So you're going to see million metric tons of carbon dioxide, and you're going to see million metric tons of carbon dioxide equivalents. So the million metric tons of carbon dioxide is just carbon dioxide, while million metric tons of carbon dioxide equivalents includes more greenhouse gases converted to carbon dioxide equivalents using their global warming potential. Now, all of these definitions are listed in chapter 167, but for those less familiar with the lingo, global warming potential is a measure of the heat absorbing ability of a particular greenhouse gas relative to CO2. It's a lot more complicated, of course, including decay rates, et cetera, but that's the general idea. So how much more does a gas contribute to warming compared to CO2? And so using that conversion factor, that global warming potential, we can calculate the CO2 equivalent and be comparing apples to apples. So you're going to see both million metric tons of carbon dioxide and million metric tons of carbon dioxide equivalents as we go through the data, and just note the differences. Now, you're also going to notice references to both source categories and energy sectors. Source categories are categories of activities generating greenhouse gases and include energy, agriculture, waste, and industrial processes. Now, all greenhouse gases can be allocated in one of these four source categories. Now, the energy source category is further broken down by energy sector. And this is how we isolate emissions for transportation, residential, commercial, industrial, and electric power sectors. Now, I know it can be confusing, don't get me wrong. The industrial processes source category, for example, is not the same as the industrial energy sector. The industrial processes source category represents emissions from industrial processes that do not involve the production of energy. So emissions from processes like refrigeration and fire extinguishing, while the industrial energy sector describes emissions from burning fuels to generate energy within an industrial setting. So things like burning fuel oil or natural gas in a boiler or an engine. So now, I don't expect you to see this, so no need to squint, but I wanted to show this for clarification. There is a table in the appendix that you can use as a resource should you be interested. And this table breaks down emissions by both source category and energy sector, and it shows you how they can be added up, because I know there was some confusion about that in the last report. All right, so let's get back to the data. So here are gross emissions by source category for 2019. Now, one of these pieces is a lot bigger than others, right? Energy. Our consumption and demand for energy lead to the lion's share, 91% in this case, of Maine's gross greenhouse gas emissions. Agricultural activity, industrial processes, and waste disposal combined only contributed 9% of the 2019 gross greenhouse gas emission total. Now, this 9% is still important, and we have strategies to reduce these emissions, but energy certainly gets the most attention, and this is why. Now we can break down that big blue piece of the pie over time and look at the different energy sources we depend on here in Maine. So you can see here how our reliance on energy has changed over time. And you can see that our total consumption has decreased over time. In fact, in 2019, our total energy consumption was 26% less than in 1990. Now remember that emissions of CO2 from burning fossil fuels accounted for 60% of Maine's 2019 gross greenhouse gas emissions, and fossil fuels include things like coal, petroleum products, and natural gas. You see those on this figure. Now, the big blue piece in this figure is petroleum. In 2019, petroleum products accounted for 47% of all energy consumed, 49% of gross greenhouse gas emissions, and 82% of carbon dioxide emissions from the combustion of fossil fuels. Now, let's break this piece down a bit further. Again, just this blue segment down at the bottom. So this figure shows our consumption of different petroleum-based fuels over that same reporting period. And you can see the biggest here, right? Motor gasoline in blue at the bottom and distillate fuel above that in red. I also want to point out that orange segment toward the top, that's residual fuel oil. And the reduction in the use of this fuel, which is 95% since 1990, is a large driver of the overall decline in Maine's gross greenhouse gas emissions. Now, some of this can be explained by an increase in natural gas. There's actually been a 912% increase in natural gas consumption between 1990 and 2019. And flipping back here, you can see this green segment in this figure that represents natural gas. So you can see where it popped up and where the residual fuel, that orange segment, starts to drop off. Now, there's more good news here. Petroleum consumption in Maine has declined by 33% between 1990 and 2019. And linked to that, CO2 emissions from burning petroleum-based fuels have also decreased by 33%. So next, we can break down petroleum consumption by energy sector. So all sectors have reduced consumption of petroleum since 1990, which is great, some more than others. The transportation sector has been the leading consumer of petroleum for all years, but the sector has decreased its petroleum consumption by 14% from 1990 to 2019. The residential sector has reduced petroleum consumption by only 0.4%, while the commercial, industrial, and electric power sectors have achieved significant reductions. So commercial at 37%, industrial at 78%, and electric power at 98%. Now, switching to emissions, this figure shows that the transportation sector produced almost half of all CO2 emissions generated from burning fossil fuels in 2019. The residential sector accounted for the next highest contribution at 21%. Now, expanding this to look at the full reporting period, we see that the transportation sector has been the leading contributor of CO2 emissions for all years, so 1990 through 2019. But the sector has managed a decrease of 11.5% in CO2 emissions during that period. The industrial, electric power, and commercial sectors have all also reduced their CO2 emissions during the reporting period. Commercial at 21%, industrial at 51%, and electric power at 65%. Now for electric power, if we just look at that period from that peak emission time in 2002, all the way through 2019, that sector shows a 91% reduction. And now let's look at residential. Well, there's a lot of variability over that reporting period. As you can see here, the residential sector has seen an overall increase of 1% during the reporting period. So these are CO2 emissions from burning fossil fuels. And we know that in 2019, this accounted for 60% of total gross greenhouse gas emissions. And this is why emissions from CO2 from fossil fuel combustion are often primarily focused on when assessing greenhouse gas emissions. However, additional greenhouse gases such as methane and nitrous oxide and others are also produced during the fossil fuel combustion process, and combustion of renewable fuels generates biogenic greenhouse gas emissions that we have to consider when we're talking about a complete gross greenhouse gas inventory. So let's look at that. Let's look at all gross greenhouse gas emissions from each energy sector. So again, these are just the energy sectors, not all of the source categories. Now, these emissions include all greenhouse gas emissions produced through the production of energy. So that's including non-CO2 greenhouse gas emissions and greenhouse gas emissions from the combustion of renewable fuels. Now, you can see here the purple line, that's the industrial sector, and that had the highest emissions early on in the reporting period. But the transportation sector, you can see that that rose above industrial, and it's been higher than the industrial sector since 2009. Now, most sectors have reduced total emissions since 1990. I think you can see that here. Transportation has a reduction of 8%, industrial 53%, commercial 10%, and electric power at a 41% reduction. Now, for transportation, commercial, and electric power sectors, these decreases are linked to reduced burning of fossil fuels. And for the industrial sector, emissions from fossil fuels and combustible renewable fuels are both about 50% lower than they were in 1990, which is great. Now, the residential sector, we see emissions have decreased by 15% over that reporting period, increased. So you see an increase in this red line here. And CO2 emissions from burning fossil fuels within that sector are very similar in 2019 to what they were in 1990, but emissions from burning renewable fuels have increased. Now, switching gears a bit, this is what I mentioned was an additional added piece to our report. Let's look at emissions from electricity. So in the past, we've received a lot of questions about this data set. So we've added another component. We can now compare production-based emissions with consumption-based emissions. And let me explain a little bit more. Our gross greenhouse gas inventory is referred to as a production-based inventory. And that means that we count emissions that are produced in Maine. So if you imagine a giant barrier around the state and only the emissions produced inside Maine are seen by the atmosphere. And in this case, we do not count emissions from electricity produced outside of Maine, even if they're used in Maine, but we do count emissions from electricity produced in Maine, even if it's exported and used outside of the state. So this is the standard method because it's physically what's happening here, and it helps to prevent double counting when looking at multiple state greenhouse gas inventories at once. Now for electricity, consumption-based emissions are emissions from the generation of electricity used in Maine. So if the electricity is used in Maine, no matter where it's produced, those emissions are counted. Now, technically, the atmosphere above Maine might not directly see those emissions, but there's no line in the sky, and you could argue we're responsible for those emissions because it's our demand for that electricity that's creating those emissions elsewhere. Now, to be as transparent as possible, and because we know many are interested in these data, we've added some figures to show the differences. Now, do keep in mind that the consumption-based emissions are not yet available with biogenic emissions. So the dark blue line in this figure, that's our normal method. That's the production-based method, and it does include biogenic emissions. Now, to compare apples to apples only, I've removed biogenic emissions from the production-based emissions in the light blue line. So what you want to compare here is the light blue line, the production-based emissions, with the green line, that's the consumption-based emissions. Now you can see that the consumption-based emissions are a little higher, and that is in part due to a different mix of energy sources used to produce electricity outside of the state, as well as the fact that we are currently a net importer of electricity. And here you can see imports and exports of electricity. So positive numbers here represent imports of electricity to Maine, and negative numbers represent exports from Maine. So the green line is the international exchange with Canada. The blue line is interstate exchange with other states. And the orange dashed line, that's the net total exchange. So that orange dashed line being above zero indicates that we've been a net importer of electricity recently. Now, next, let's look at emissions from renewable energy sources. So here we see wood emissions by energy sector. And overall, emissions from burning wood have decreased 32% since 1990. Now, with the exception of 2014, the industrial sector, that's that purple line at the top, has been the lead emitter from burning wood. Now, the electric power sector, that's the blue line, has historically been the second largest contributor, but it fell below residential in 2019. So both industrial and electric power sectors have reduced emissions from burning wood. Industrial emissions in 2019 were 54% lower than in 1990, and the electric power sector was 13% lower. Now, the use of wood for energy has increased by 50% in the in the residential sector. That's the red line here. And in comparison to other sectors, the commercial sector, the green line, relies very little on this renewable fuel for energy. So next, let's look at some more renewable fuels. This is ethanol and biodiesel. So the transportation sector utilizes both of these renewable fuel sources to generate energy. Biodiesel is currently limited to the transportation sector, while fuel ethanol is used by the industrial and commercial sectors too, but in much lower amounts. Now, transportation began mixing fuel ethanol with motor gasoline in 2005, and biodiesel use by that sector began in 2007. So while you can see in this figure that the consumption of both of these renewable fuels has grown, they represent a very minor contribution to Maine's gross greenhouse gas emissions right now. In 2019 specifically, fuel ethanol emissions were 1.6% of gross greenhouse gas emissions, and biodiesel was only 0.2%. But we're still tracking them. All right, so let's switch gears again and let's look at the money. In this figure, time is our horizontal axis as usual, but now we have two vertical axes. At the left, we have gross domestic product, or GDP, which can be used with the dark blue line. And on the right side, we have gross greenhouse gas emissions in million metric tons of carbon dioxide equivalents. So as you can see, the economy is growing. That blue line is going up and up and up. And at the same time, our gross greenhouse gas emissions are decreasing for the most part since that peak in 2002. Now, when we combine these two lines by dividing gross greenhouse gas emissions by GDP, we see that declining trend in emissions per $1 million of GDP. This 53% decrease from 1990 to 2019 indicates that Maine's economy is transitioning to lower carbon emitting fuels, more efficient equipment, and industries that require less energy per dollar of GDP. Now, this wraps up the gross greenhouse gas data that I wanted to share with you. And next, we're going to pull in sequestration and see where we are on this path toward achieving carbon neutrality. You ready? All right, here it is. This is the first ever Maine carbon budget. This is the first net greenhouse gas inventory for Maine, the first attempt at quantifying where we are in terms of carbon neutrality and how far we have to go toward achieving our goal of being carbon neutral by 2045. Now, first, let me thank the folks listed at the bottom of this slide from the University of Maine, the Maine Forest Service, and Biggs College who completed this work. Pulling this carbon budget together was no small feat, and each number you see in this graphic required a lot of effort from a lot of people. So it's convenient that it can fit onto one slide so you can take it all in, but don't let that mask how valuable this is. Now, let me walk you through it. So these data are based on a 10-year window ending in 2016. So you're looking at the flow of carbon through the system. As you can see, there are many sources and sinks to consider. The primary categories are in boxes along the middle. So we have fossil fuels, wood products, forests, wetlands, agriculture, urban areas, inland waters, and coastal waters. Now within each of these boxes, you can see sources and sinks of carbon emissions. Positive numbers represent emissions up into the atmosphere, and negative numbers indicate sinks or sequestered carbon. You can see smaller boxes at the bottom between categories. Those show flow between categories. For example, you can see carbon linked to wood harvested from the forests. While some of that decays or is combusted, some is retained in wood products, reducing the amount of carbon emitted to the atmosphere. Now, the boxes along the top show net exchange between these categories and the atmosphere. And the boxes in the blue area are subtotals and totals. So let's look at those top total boxes. First, see the forest and wood storage box, 75%. That's the fraction of greenhouse gas emissions sequestered in the forest if we just consider the forests and wood product categories along with emissions from burning fossil fuels. Those are the largest contributors, right, to the net inventory. Now, we can add in wetlands, agriculture, urban areas, and inland waters to get a net land sink of 79%. And finally, we can look at the complete budget, including coastal waters, and we can see that 75% of gross greenhouse gas emissions are offset by sequestration in the environment. And 25% of our gross greenhouse gas emissions, that's the airborne fraction, remain in the atmosphere. So when we achieve carbon neutrality, that airborne fraction will be 0 or less. This is an incredibly useful snapshot of how carbon flows in the state, and work is already underway about updating these data through 2021 for the next biennial report. Now, another frequent question we receive about this work is about forest carbon markets. So participation in carbon markets is growing in Maine, nationally and internationally. In fact, among the recommendations listed in the final report of the Governor's Forest Carbon Task Force was exploration of a voluntary credit-based or practice-oriented carbon program for woodland owners of 10 to 10,000 acres. So this is another area where we receive a lot of help from the University of Maine, and in this case, the Forest Policy and Economics Lab. For those interested, I've provided the link for you at the bottom here so you can see all of the data. And based on these data, as of 2016, and that's the reporting window we looked at for the carbon budget, there were 6 forestry products with carbon offset credits listed. Now, some of these projects are 4 years and others are 93. When we add up the offsets listed for each project and divide each project's duration, the annual average sum of these 6 main forest projects was 0.9 million metric tons of carbon dioxide equivalents per year. Now, while this number is relatively small compared to Maine's gross and net greenhouse gas emissions, the department is still going to continue to track these projects and report carbon offsets, and we'll see how these grow in Maine. All right, so we've seen the carbon budget and know that in 2016, we were about 75% of the way toward reaching carbon neutrality by 2045. But a time series is really helpful to see where we've been and where we're headed. So again, let me thank researchers at the University of Maine and the Maine Forest Service for pulling this data together. What you see here are historical and projected Maine greenhouse gas emissions. So these are based on gross greenhouse gas emissions as well as forest carbon data. The light blue line at the top, that shows gross greenhouse gas emissions, including biogenic emissions. These are the data we looked at earlier this afternoon. Now, the solid line is the data that we know, and the dotted blue line from 2020 through 2050 is a projection crossing through our 2030 and 2050 reduction goals. Now, the green line at the bottom of the figure represents the forest carbon sector. This represents forest contributions to carbon uptake in the form of growth, wood products, and wood used for energy. So these all add up to the carbon removed from the atmosphere. Now, if we subtract the total forest sector C line from the gross greenhouse gas emissions, we get that net exchange of greenhouse gases. And that's that dark blue line in the middle. That's the line that needs to be 0 by 2045. And as you can see by the dotted projection line, we're currently on track to meet that goal early. Now, let me add, while I think this projection is very helpful in visualizing our goals, there are a number of major assumptions. So we assume a continuous glide path of gross greenhouse gas emissions, assuming they pass through our 2030 and 2050 goals. So we have to meet those goals. So we also assume that we achieve, so that's the 45% reduction and the 80% reduction by 2030 and 2050. We also assume that the relatively high rate of forest carbon sequestration in the recent past compared to historical standards will be maintained indefinitely. We don't know if that's going to be the case. This does not accommodate for potential increases or decreases in forest carbon sequestration rates in Maine due to any management, new incentives, forest disturbance, or natural forest successional processes. So there are additional caveats, of course, but you get the general idea, right? It's projection, and it won't become reality unless we work for it. So let's recap a little bit here and run through some of the major highlights. Forgive me for reading these, but I thought it would be useful to summarize these on a bulleted slide for you. So gross greenhouse gas emissions in 2019 were 25% below 1990 levels. Maine is approximately 75% of the way toward carbon neutrality, which means 75% of gross greenhouse gas emissions are offset by sequestration in the environment. Carbon dioxide emissions from fossil fuel combustion in the electric power sector have decreased by 91% since they peaked in 2002. So that's largely by replacing high carbon fuels with lower carbon energy sources, primarily natural gas and renewable sources. Gross greenhouse gas emissions per $1 million of state GDP were 53% lower than 1990. In other words, Maine's economy has grown while greenhouse gas emissions have declined. 91% of gross greenhouse gas emissions are the result of energy consumption. 60% of gross greenhouse gas emissions are CO2 from the combustion of fossil fuels. And 49% of CO2 emissions from the combustion of fossil fuels are from the transportation sector. And the transportation and residential sectors have both the highest consumption of petroleum and the highest emissions from burning fossil fuels. Now, so much of this great news is to be celebrated, but we clearly have work to do if we want to reach our future goals. So let's take another look. Here are the gross greenhouse gas emissions along with our future reduction goals. So that dark green line at the top there, that's the data we know. That's the data we looked at earlier in this presentation. Those are the gross greenhouse gas emissions from 1990 to 2019. Now the dotted line is the 1990 baseline on which we base our reduction goals. And the 3 dark blue dots, those represent our future goals. Now you can see we've successfully achieved our 2020 goal, which is awesome and hugely encouraging. Now, based on the slope of the line in recent years, we are on track to meet our future goals in 2030 and 2050. But that requires we continue realizing the emission reductions we've achieved in the last few years, and that is going to take work. Now, remember, these data predate Maine Won't Wait, and following the strategies outlined in that climate action plan is how we're going to achieve the emission reductions we need to meet our 2030 and 2050 goals. So I'm going to end here and happily take any questions that you might have.
First of all, I just want to, I'm sure that you're all feeling the same. Stacy has done an amazing job and I know Melanie and the whole team helped to contribute to this, but Stacy, a ton of heavy lifting, and you explain it very clearly for at least those of us who are not experts. So lots of hand clapping for you, but thank you very much for that. So we will open it up to questions from Climate Council members and co-chairs who are on this call. I did wonder, Stacy, though, if you could provide a little bit of context about your work with other states and sort of, you know, we, all of us, you know, work in different ways with our colleagues from other states. We work with U.S. Climate Alliance states. Obviously, the federal government is taking a more active role in thinking about this. But can you just talk a little bit about both the components of both emissions reductions, but also sequestration and sort of the apples to apples comparison between states?
Yeah, sure. So there's a lot of collaboration that goes on between states in all areas of emissions inventory, not just greenhouse gas emissions. And so that's where it comes in. It's in those group discussions. And we talk about our methods. We talk about who's using what, who's doing new special things. For example, Vermont surveys folks about their wood use. And so that was one of the things that we did. We kind of followed their lead there. Most states are starting to think about biogenic emissions related to their greenhouse gas inventory. A lot of states report it, and a lot of states are starting to think about how they can do a better job of incorporating it. And so there are states actually following our lead and looking at our methods. What are we doing? How are we compiling this data? So I suspect you're going to start seeing more states requiring this data in their reports and starting to consider it in terms of their goals. We work very closely with U.S. Climate Alliance. All of those states tend to be interested in similar data and similar methods. That is probably the the primary means of communication specific to greenhouse gas emissions inventories, because there are other states that are looking more closely at EPA's greenhouse gas emissions inventory. They have an emissions inventory now that's broken down by states, but EPA will be the first to admit that it's not perfect, right? So as I mentioned at the beginning, we use EPA's state inventory tool as a foundation, but we make a lot of changes because we know that we have better data. And so some states are considering using this kind of default state inventory that EPA is providing. And that's great for states who don't have an inventory. But for us, we know that ours is more accurate. So there's a lot of discussion about that.
Thank you, Stacy. So we have a question from Ken in the chat and then Anya. So I'll just read it so everyone can see it. But can you characterize in lay terms the biogenic emissions associated with energy consumption and energy production versus, say, decay? So that's a question from Ken Coburn.
Can you repeat that? What?
It's also in the chat if you can see that. Can you characterize, and Ken, feel free, you can ask the question as well. You're out there.
Sure, Stacy, I was just curious what the biogenic emissions are. Are there any positive emissions, or are the biogenics, are you just talking about the negative side, the sequestration?
So there are both. So when we combust renewable fuel sources like wood and biodiesel and ethanol, there are emissions that go up into the atmosphere. And so we're counting that. But we are also counting the carbon that's sequestered by those same energy sources when they are grown. So there's a balance. And that's why we have to include the biogenic emissions in our gross inventory, because we want to count that negative side, that sequestration, in the net inventory.
Sounds good. I'm a little surprised the biogenic positive was that high, but it's still vastly negative to our great advantage. Thank you.
Great, Anya.
Yeah, thanks. And Ken, your question was one of mine, so thank you. And thanks so much, Stacy, for that awesome presentation. I haven't had a day to sit on the beach and read this yet, so really grateful for your time. I have two quick questions, neither of which I don't know if this is the right space to ask them or not, but I'm curious. I know you were talking about the forest sequestration and the assumption that it would stay at the same level. Is there any analysis either from your office or Hannah, maybe this, or Commissioner Loisam, maybe this is a question for you too, but is there any analysis as to how likely it is that we stay at that level of sequestration? And then my second question is, in terms of, I know the report looked at many different types of greenhouse gases, you know, carbon dioxide, methane, et cetera, and just wondering if there's anything in the report talking about emissions reductions or gains based on specific types of greenhouse gases. Like I'm thinking about like methane that has a higher warming potential and like how that can impact our role in climate change. So happy to rephrase either of those questions, but
yeah. So I'm going to answer them backwards. Yeah, the report looks at a lot of different types of greenhouse gases. We mentioned carbon dioxide, nitrous oxide, methane, but there's also, you know, the HFCs, the PFCs, the SF6, all of those are included. For my work, I do separate out the gases so that I can add them up and make sure that we are converting to carbon dioxide equivalents appropriately. So I have the breakdown by gases. But to my knowledge, we're not looking at any specific strategies related, like targeting a specific gas. But that's more of a policy question that I will leave up to Hannah and Melanie. But I can tell you that we have the breakdown. So if anyone's interested in seeing those data, we do have those. And the global warming potential is important, right? And that changes over time. And we are using the most recent global warming potentials listed by the IPCC, the Intergovernmental Panel of Climate Change. So we're using the AR5. There was an AR6 released in 2021. And so for our next report, we'll be updating those global warming potentials so we can stay current and ensure that our reporting is as accurate as possible. Now, for the sequestration going forward, what I can tell you is that the governor's Forest Carbon Task Force really looked at this a lot and tried to find ways that we could increase that sequestration. But as far as projections other than the one that we have here, I don't know, but I know someone on this call might be able to answer.
So let me just chime in on on that end. We're on the forest sector, we're on sort of the high end of sequestration by way of accumulating carbon in the forest. And so the challenge will be, don't mess it up, continue to maintain that high level and perhaps increase it. In addition, though, there's, and that doesn't go on forever. Eventually you biologically, ecologically, you can fill up the forest. And so that end of sequestration is not eternal. Products, on the other hand, are an area, particularly durable products, cross-laminated timber and things that I know we've all heard about and talked about. That can be expanded. There's limits, but nevertheless, that can be expanded significantly. So it's a combination of trying to maintain the high level of sequestration, perhaps increasing it as a result of some of the policies and recommendations like the Carbon Task Force, and invest in and expand some of the emerging forest products and some of the traditional heritage industry as far as forest products that are durable and lock up carbon for many decades or longer.
And I was just going to add, I don't need to remind this whole group, obviously there's a variety of strategies in the report, in addition to what the Carbon Task Force worked on, the 30 by 30 goal. So obviously attempting to retain the lands, whether it's, working forest or farmland or other natural lands in the state of Maine that we could lose due to development. And I actually am imagining that will continuing to discuss that topic, and that data will be another area of focus over the next couple of years. I also just add, Stacy talked about other policies, and I would say specifically like HFCs. Melanie's team is implemented rules to phase down the use of HFCs. So there are specific policies. I'm sure there could be another area of topic and discussion. So Sandy.
Stacy, thanks again for how you put all this stuff together. It's almost like magic.
It's not, I promise.
One thing that strikes me is the importance of natural climate solutions. I mean, you've referred to this in a number of ways for the importance of conservation of near shore and inland forests and wetlands and marshlands. So that's always a good outcome, I think, is to increase conservation so that you can let the natural environment do the sequestration. Additionally, there's a great group of folks that have been working on the hypothesis that you can maintain harvest in the forest while increasing carbon sequestration. A number of UMaine scientists are on this project, along with a number of others. We're hoping to have that project wrapped up. It's been 2 years now that we've been running this with large commercial landowners, and I can't wait to see the final report. I've seen some drafts of it, but believe me, as soon as that's up and ready, we'll be sharing that with everybody. So I wanted to say something about that. And I also just am curious, as everybody in Maine is, I'm sure, aware, there are a lot more cars in Maine in July and August. When you're studying vehicle miles traveled, are you studying cars that are coming in over the Piscataqua River Bridge, as well as those of us who've got Maine plates on our cars?
Yeah, so that's a common question. And we are basing this on, there are traffic counts that DOT does. And so we don't know whose vehicle it is, if it's a Maine vehicle or an out-of-state vehicle. So we are counting, ideally, all of the vehicles that are on the roads.
Yeah, I bet you see a real increase in the curve starting about Memorial Day and wrapping up around Columbus Day.
It's funny though,
people-
a lot of folks in Maine though leave the state too. So
Yeah.
there's some balance there.
Why would you leave Maine in the summer? Yikes.
Yeah, and I haven't seen a lot of the seasonal data. Most of the data that I look at is on an annual basis because that's what I pull into our report.
Yeah, well, thank you for taking a lot of this information, putting it in a digestible form.
You're welcome.
And just to clarify, I mean, that is a common question. I feel like we all are like, what's the answer to that again? But if you buy gas in the state of Maine while you're driving around the state of Maine, that would also be reflected.
Yes.
Okay.
Yep.
Yeah.
Yeah. So there are two methods that we use to look at emissions from transportation. One is the combustion of fossil fuels, right? And that's allocated to transportation. And so that is fuel based, that is fuel consumption based. That's the CO2 piece. And then the vehicle miles traveled that we get from DOT is what we base the methane and nitrous oxide emissions on.
Great. Any other questions or comments for Stacy or Melanie? You can ask Melanie hard questions too. All right, Melanie, any last comment from you?
I would like to thank Stacy for all of her hard work on this. You know, she really has done a tremendous amount of work. Also, thanks to Ivan and others from the University of Maine for their work, particularly around the sequestration side. You know, we couldn't have produced this analysis without that partnership. And so this has been, I feel like, a huge step forward in the way that we in Maine are looking at our emissions. This is a much fuller picture. And I think it's going to help us as we look at policy strategies and the success of our strategies moving forward. So I'm glad that we were able to get this out for all of us to have this understanding of, you know, what we had accomplished through 2020. You know, look forward to what we see in the next data set, because like Stacy, we tend to really like numbers. So I'm excited to see what the next data set looks like so we can compare it to this one. Excellent,
Melanie. Thank you so much. And again, huge thanks to Stacy and another thanks to Ivan and the UMaine team. So I think that sets the stage well. Obviously, we're about almost 2 years into our climate plan, and we're already starting to think about the next one. And I think this really does set the stage for some different ways of thinking about how to continue to implement this plan. So we have our next meeting is September 14th. We're still determining the details of timing, and so we will keep everyone posted on that. But you will, I'm sure, spend the rest of your August reading climate information on the internet, reading every table of Stacy's incredible report. Cassie just put the meeting will be posted on our webpage, as well as the slide deck, which is a very helpful summary of the whole thing. So, and hopefully in September, we'll have continued good news to talk about. Maybe Washington will continue to move forward on the issue of climate to help Maine do all of our heavy lifting. So with that, don't see any other questions or comments. We'll see folks in September.